Welcome, listeners, to our next topic of discussion on coastal processes and landforms. And this is in the series of our discussion on fundamentals of geology. And like we have discussed earlier on the various erosional and depositional landforms formed by river, wind, and glacier. And so, this is the last one on that set of your erosional and deposition landforms. So now we will be looking into again the depositional landforms and erosional obviously landforms related to the wave action related to a sea or an ocean. So to start with the idea of your coastal landscapes. So obviously coastal landscapes are landscapes that are formed due to the action of the wave or the current action of the seawater or ocean water. So the oceans have a great impact on the earth and its climate obviously. So coastal regions are unique and very dynamic environment and it also presents a very beautiful opportunity to study the different processes that are related to the processes of mean sea level changes from time to time and obviously events of marine transgression and regression like we discussed in our discussion on principles of stratigraphy. So they involve the transformation of mass and energy through waves and currents. Shorelines are always subjected to both continental and oceanic processes. So that's why there is a mix information you might get as well. So your waves, tides and currents are very powerful geomorphic agents, and most of the Earth's coastlines are relatively new and are setting for continuous change. The erosional and depositional work of the sea waves can create many spectacular landscapes along the borders of the continents, obviously in the continental margins like this. So you can see there is a contact in this photograph, there is a contact between this continental landmass and sea, and between that there is a beach region that can be seen here. Apart from that, you can also have a direct contact between your continental landmass and the sea or ocean, and this understanding of the presence of a beach or not, that whether in the continental margin at some place whether there is will be development of a beach or not, or whether the beach area is dominated by rocks. So this understanding is also very important, because wherever you go to any coastal region, either it is dominated by a beach or it is also dominated sometimes by rocks, sometimes also some biological materials like your coral reefs. So this understanding of coastal processes and the kinds of erosion and deposition related to it is extremely important. So the interaction of your vast oceanic and atmospheric masses is dramatic along a shoreline. So at times the ocean attacks the coast with its erosive power. At other times the sea breeze, salty mist and repetitive motion of the water are gentle and calming. So you can see there is a continuous interaction between the ocean and atmosphere and the land masses, and resulting into formation of various types of coastal landscapes. So one by one we will be looking at the different coastal landscape. First we will be looking at the landscape strictly formed under erosional feature or strictly as a result of erosion. Then we will be looking at the depositional features, and also there are features which are giving you a combined and kind of a landscape generated by both erosion and deposition. So but before that we need to understand what a wave is, or how the sea current interact with the land masses. So your waves are result of wind blowing over the sea. As they approach land, they break. The bottom of the wave touches the sand and slows down due to increased friction. So the top of the wave becomes higher and steeper until it topples over. So this is a very schematic and simple diagram that you can see, where you will be looking at the waves. These are the wave crest and trough. This is the direction of the movement of the wave, and obviously when it is toppling down, at that time there is an orbit that becomes elliptical due to shore friction, slowing the base of the wave. So then obviously your breaking wave will gain height and finally will reach the beach, or you can say the shoreline. So waves have a circular orbit like this, but when it comes near to the shoreline, it becomes an elliptical orbit like this, and there is always due to this rotational movement of the waves, there is always this coupled event of swash and back wash. So when the wave is going towards the shore, it is considered under the event of swash, and again when it is moving away from the shoreline, then it is considered as back wash. So this continuous cyclical pattern of swash and back wash is the main, you can say, main feature or the main controlling or influencing factor of all these kind of erosional and depositional processes. Talking about the types of waves, broadly there are two kinds of waves, constructive ones and destructive ones. If I take the example of the Indian peninsula, then the Bay of Bengal, or the waves along the coast of the along the eastern coast, that is on the Bay of Bengal side, the waves are generally destructive in nature, apart from a few regions. But if I look at the western margin of the Indian peninsula, then I can say that the waves are more constructive in nature, where you can see a growth in the beach over a large span of time. So your constructive waves have a strong swash and weak backwash, so deposition is much greater than erosion. That's why sometimes your beach will grow with time. And in case of destructive waves, have a weak swash and a strong backwash, so erosion will be much greater than that of deposition, so leading to the destruction of, you can say, the beach deposits that are already present in that beach. So again, if I look at the schematic diagrams of this constructive wave, then you can think of a strong swash and a very little backwash. So what will happen, it will give you a gently dipping slope of the beach, and obviously this weak backwash will not erode the material that are already present on the beach. They will definitely erode. Whenever there is a backwash, there will be some erosion, but as the swash is very strong, so it will be adding more and more beach sediment in comparison to what it is getting washed away from the beach. On the other hand, when you are looking at a destructive coast or a destructive waves are involved, in that case the backwash component is much more in comparison to that of the swash component. So in that case, what will happen, that obviously there will be more erosion than deposition. So likewise, the beach will be destroyed over a large period of time, and what will happen after that, that the slope of the beach will also increase. So these zones are pretty risky. Means if you are going to take a bath in the sea water, or you are going for sea surfing, in that case these zones are relatively more risky than the constructive zones. So here you can see that this, due to the strong backwash, it removes the sand from the, and increasing, obviously it will remove the sand from the beach, and it will also increase the slope of the beach over the time. So you can think of, again, like I was mentioning, constructive beaches and destructive beaches formed in response to the constructive waves and your destructive waves. Then you can think of erosion at coast or your coastal erosional processes. There are a few kinds of erosional processes that are involved whenever the seawater is in contact with the land mass along the shoreline. Then your subaerial processes. Why subaerial? Because obviously there will be processes which are going on just beneath the water level, as well as there will be processes that will go on just above the water level. So there is a kind of a subaerial process. It is not submerged completely, it is not completely aerial. So that's why subaerial processes include weathering and mass movement. These processes operate on the cliff face to weaken it and provide material for coastal erosion. So there are various ways of this coastal erosion. The first one is obviously the hydraulic action. This process involves the force of water against the coast. So this is the kind of hydraulic action you can look at this diagram, the waves enter cracks or joints or sometimes faults in the coastline and compress the air within the crack. When the wave retreats, the air in the crack expands quickly, causing minor expansion or explosion kind of thing. This process is repeated continuously, leading to, you can say, the scouring of material from the cliff. Then you have the process of corrosion. This is the chemical action of the seawater. The acids in the salt water slowly dissolve rocks on the coast like this, and limestone and chalk are particularly prone to this process, because you remember from our discussion on sedimentary rock that limestone is a chemical or biochemical non-clastic rock. So obviously limestone will be also more prone to different chemical reactions, and as the main constituent is calcium carbonate, that's why it reacts with the seawater very quickly. So then you have the process of attrition, where materials carried by the waves bump into each other and so are smoothened and broken down into smaller particles. So the process of attrition is also common in case of wind erosion or your river erosion. It is not possible in case of glacier erosion, because in case of glacier, the fragments, rock fragments or sediments, they are kind of trapped in its own space. So they don't have the scope much to collide with one another and disintegrate one another into finer particles. And finally, abrasion, which is also the most common type of mechanical weathering, that is, so this process by which the coast is worn down by material carried by the waves. Waves throw these particles against the rock, sometimes at very high velocities. So that's how your abrasion works. So you have these processes of hydraulic action and corrosion, then your attrition and abrasion, that will always be responsible for the erosive nature of the coastline. Now also, if I look at the landforms that are formed purely by these erosional processes, then first, obviously the first one that is very characteristic is the cliffs and wave cut platforms like this. So if there is a cliff earlier existing like this, then by the repeated process of your hydraulic action, corrosion, attrition and abrasion, obviously the coast cliff of the coast might retreat due to repeated phases of weathering. Similar it's very similar to like that of the retreating waterfall. Means it looks like that, but obviously the agents were different at that time, as well as the composition of the hard rock and soft rock that were present beneath a waterfall are obviously different in that case. But here simply if I look by the geometry, I'll say it is also retreating. Similarly, waterfalls have a habit of retreating with time. So here also cliffs also have a habit of retreating with repeated events of erosion through your corrosion, abrasion and hydraulic action. Then you can have some spectacular structures like or geomorphic landforms due to the erosional features of sea waves, like caves like this, then headland, then obviously sea arches, and also some tall rock stack. So starting, if I look at look across a shoreline that has obviously it is not being separated with a large beach. In that case, when the shoreline is kind of that the rocky landmass is very near to that of the sea, and the sea is continuously interacting with the rocky landmass without having a large beach in between, then the large cracks that might open up, and obviously it will result into the initiation of the hydraulic action. Then the crack grows into a cave by hydraulic action, also by abrasion. Then also this crack becomes larger with time, and it might result into formation of a sea cave. Then the cave breaks through the headland, forming a natural arch. So your natural arches are beautiful and spectacular structures. We'll see one of the examples of it. The arch is then eroded and sometimes collapses, leaving a tall rock stack like this. So this is the direction of retreat. You can say again it is related similar to the retreat of the cliff, and the wave cut platform will increase here. So likewise here also the cliff will retreat and the wave cut platform will increase. Sometimes the stack further is eroded, forming a stump. So this is one of the most spectacular feature you will get to see in the Andaman and Nicobar Islands of India, that there is a beautiful sea arc in the Neil Island in this Andaman Nicobar Island chain. So this sea arc has been formed as a result of a headland erosion activity of the sea. And I was again very fortunate enough to go to this place, and these parts just along the shoreline, here you will see several coral reefs, both living and dead coral reefs are present over here. So you can see there is a continuous interaction between the land mass and the sea wave, continuously leading to the formation of this kind of naturally formed sea arc. Then other erosional landforms of the coast presents, again if I look at now the three-dimensional view, I can think of the sea stack like this, sea arch like this, sea caves present here, and also there are different level of terraces. These are wave cut platform, they are referred to again as terraces. Talking about geometry again, it exactly again the geometry also looks like the geometry of river terraces, but obviously in case of river terraces they are present on both the river banks across the river channel, but in case of your sea terraces they are obviously present on the one side, that means on the landward side of the coast. But geometrically they are also step like feature like that we get to see in case of a river terrace. So these are some former sea cliffs that are present. This is the present one. There is some deposition of some sand here, and there could be also sometimes along these sea terraces or marine terraces, which are also referred as marine terraces, there could be some landslides if some toppling is going on, or some instability in the slope, or if the angle of repose increases more than for example 40 degree, 45 degree. In that case there will be toppling resulting into formation of certain landslides, and these landslides if they are of large scale or huge scale, remember again that can be again related with the very rare but a few reason for initiating a tsunami, like we discussed in the different causes of tsunami. Obviously the earthquake, apart from earthquake and volcanic eruption, and the third one, though a rare one, but a marine landslide or this kind of large scale coastal landslide may also trigger a tsunami. Obviously not of that scale of an earthquake or a volcanic eruption, but still it can trigger. Then talking about again about the marine terraces or the coastal terraces like this. So you can see just by looking at this diagram, there is again a beautiful drone image of a coastal terrace, or you can say marine terrace, where earlier you can say that obviously the sea was somewhere here along the upper terrace. Now it is beneath this terrace. So there is, you can say, this is the formal cliff, then you have a shoreline angle change, then wave cut surface again you have the coastal cliff, and this is the present day wave cut surface where your wave are continuously cutting the cliffs. So again if I look at this diagram as well, then in that case also you can see there is an upliftment here leading to the upliftment of the first marine terrace, and now you have a second terrace, and then again you have a third new terrace that is forming right now. So you can understand these processes of presence of marine terraces in some of the coastal regions. Then you also have the tendency of coastal straightening, that always the shoreline will tend or try to become straight. So the process of coastal straightening is brought about by wave refraction, deflection from a straight path. So wave energy is concentrated as it converges on the headland. So these are the headlands which are, you can say, convex outward land areas towards the sea. Again, these headland, and the concave zones towards the towards the sea are your bay zones. Like we have different seas around our earth which are referred to as some kind of bay. For example, Bay of Bengal, I can say. So there is a bay kind of a geometry it is giving. It is obviously a large sea, but it is also referred to as the Bay of Bengal. So in that case, in between you have these headlands like this. So there is a tendency for long term erosion action of your seawater, that this coastline or shoreline will try or tend to become straight, but it is not possible because of other problems. So the problem is a drift in the wave current, or which is also referred to as the longshore drift. So if this is land and this is sea, the blue is sea obviously, and here you have this shoreline, then remember that this swash and backwash mechanism is not always going in a straight path. So it is going in a kind of a means I can say it is actually deviating from its theoretical kind of an idea that it will always maintain a straight line. So due to the depending on the wind direction, in which direction your wind is flowing, there may be events of swash like this, backwash like this, again swash like this, backwash like this. And this can be also you can see observed, because means if you are going to a coastal region and if you are observing the sea waves, then you can see that every wave front that is getting created when the sea water is coming on the beach, and it looks a little bit different from the next one, from the third one, and always consequently it continuously changes unless you have a very unidirectional kind of wind direction perpendicular to the shore. So it is actually the wind direction with respect to the margin of the shoreline that what controls this motion of your swash and backwash. So if the wind direction of the prevailing wind is like this, then obviously it will try to, the swash mechanism will move parallel to the direction of the wind, and then there will be backwash again towards the sea. Again the swash will be moving in the direction parallel to the prevailing wind. So if in case the direction of the prevailing wind is exactly orthogonal or perpendicular to the shoreline, only in that case what will happen, that swash and backwash will go on continuously in a straight line. Other than that, there is always this difference in swash and backwash, against swash and backwash. So your particles on the beach are moved along as beach drift or littoral drift, shifting back and forth between water and land in the effective wind and wave direction. These dislodged materials are available for transport and eventual deposition in coves and inlets, and can represent a significant volume. The longshore current transports beach drift. So this is actually responsible for your drift of beach. So this is the updrift from where the means it is just opposite to the direction of the wind, and the down drift means it is down the direction or down the slope, like we refer in case of river, it is down the direction of the prevailing wind. So a longshore current generates only in the surf zone and works in combination with your wave action to transport large amounts of sand, gravel, sediment and debris along the shoreline. Then you have landforms related to deposition or coastal deposition. The first one is obviously beaches. So you can have beaches like this due to mainly deposition of sand. So beaches, a beach is a place along a coast where sediment is in motion. Material from the land temporarily resides where while it is active transit along the shore. You can have spits like this, smaller zones. Like a spit consists of sand deposited in a long ridge extending out from a coast. It partially crosses and blocks the mouth of a bay. Then tombolas A tombolo occurs when sand deposits connect the shoreline with an offshore island. Bars, if a speed joins one part of the mainland to the another, it is referred to as a bar. Then you can also think of your bay barriers. The speed becomes a bay barrier if it completely cuts the bay from the ocean. Means if this speed completely cuts the ocean water with the rest of the water, in that case this one will become a bay barrier. No longer it will be treated as a spit, because in case of spit also still there is circulation of ocean water inside the bay region. In this case there will be a natural blockage through the formation of the bay barrier, resulting into the formation of lagoons. You can again see now parallelly your both erosional and depositional landforms here. You can look at the headland, cliff that are going under erosion, then presence of sea arc, obviously a beach, sea stack and stump. Similarly, you can look at the depositional features like sand spit, delta, which are obviously a geomorphic feature, very distinct geomorphic feature formed as a result of the pouring of river water at the coastal region of a sea. Then obviously river is transporting material, so the material is getting deposited at the delta, so delta is also a depositional landform. Then you can think of bay, and obviously a bay barrier that might result into the formation of coastal lagoons. Coasts can or should be preserved for obviously our purposes, so that in a case of a destructive beach or a destructive wave condition, if we can't preserve the beach, so with time completely the beach will vanish at some point of time. But to preserve that, there are various ways, as also means we should also remember that the coast are also very important, because they are the main medium of transport of both human and goods across different continents or different countries and across the world. So it is extremely important to save the coast, also not only just to study the means features that are related to your erosion and deposition. It is also important to save if the erosional, or if the erosion is very high in case of a destructive coast. In that case it is extremely essential to save that from vanishing as well. So that's why jetties or groins or breakwater are sometimes installed at the shorelines to save this high amount of coastal erosion. So you can see a breakwater, a pile of rocks, and obviously cemented with some kind of material, sometimes cement as well. There are triangular or quadrangular blocks of rocky blocks or cemented blocks that you can see at some coast. If you go to a destructive coast, you will be looking into that. Even if you go to for example the city of Mumbai in India, you will see that the whole coastal area has been supported or has been delimited with this large kind of triangular or quadrangular boulders, and that are obviously man-made boulders, so that the beach doesn't go into destruction, so that you can preserve the present beach. So apart from that, you can install jetties, you can install groins to also control the drift in the sea that happens due to the periods of swash and backwash. And you need obviously harbor entrance for docking of ships, you can say, for transporting materials, also sometime human. So I'll conclude my discussion on coastal erosion and deposition here. Next we'll be moving from geomorphic landforms to we'll be moving to soils and soil profiles, where we actually are dwelling over the soil and soil profiles. So we need to understand what a soil is and how it is having a direct impact on our life and livelihood. Thank you.